Session 4.1 Visualizing Variability with a Scatterplot. For these sessions, we will use the technology to create a scatterplot. So we'll be using the calculator to create the scatterplot here. And if we want to investigate associations between two numerical variables, we'll be using the scatterplot. Scatterplot, the primary tool for examining relationship between two numerical variables. For the example, if we want to study the relationship between the size of a house and its selling price. Okay, so this is the questions about the relationship between two variables. And these two variables talking about the size of house and the selling price. And the both of them, that will be the numerical. So we want to use the scatterplot to see if they do have a relationship or not. Each point in the scatterplot will present one observation. So you will see the scatterplot will be using the dots to represent one data. Just like the example, the size of the house and the selling price. So we will be using the rectangular coordinate system. Usually create using technology such as a computer software program or graphic calculator. Okay, let's look at this example. This is a scatterplot of typical marrying age for the man and woman in the United States. And you could see the points here represent the 50 states and the District of Columbia. So it means each point represents a state and shows us the typical age at which man and woman marry in that state. Okay, so this is the example for the scatterplot. Again, one point represents one data. Examining the scatterplot. Number one trend, just like the center, we want to see the general tendency of the scatterplot. Will all the points going up here, just like the uphill, or going like the downhill, or that's a no predictable trend, okay? Second one, the strength, like the spread. We want to see if all the data is going to be close to each other or it's going to be spread out. Number three, the shape. What is the shape looks like in the scatterplot? Okay, look at the first one. The general tendency of the scatterplot has you read from the left to the right. Typical trends. Increasing. I will show you guys the picture after, okay? Increasing, just like the uphill, we're gonna call a positive association. Remember the scatterplot is tell you guys the relationship between the two numerical variables. If the two variables has the increasing data, so we say this is gonna be the positive association. It means when the size of the house is increasing, the selling price is also increasing. Decreasing, the downhill. So the scatterplot is gonna be going down like this way. This is called a negative association. Okay? No trend if there is neither an uphill nor downhill tendency. For the number three, we're gonna say that is a no linear association with these two variables. Okay, look at this example, positive trend. This is the example of the age of a used car and the miles it was driven. X-axis represent the age of the cars, how many years. And then the y-axis here, this is talking about it was driven, the mileage. We expect older cars to have been driven farther because generally the longer a car is owned, the more miles it travels. So look at this picture in here. You could see for this one, this dot, we call this is gonna be outlier, okay? Think about it. This car is about like 6 years old. Okay, the owner owned this car about 6 years old. But it's about 240,000 miles. Okay, so I believe this is gonna be the outliers. And this one, it may be the outlier as well, right? Because the age of the car is about like 23 years, but the mileage is only about 60,000. Okay, and then we're gonna see all the points is gonna be going uphill here. Okay, going uphill is increasing. So we could say the age of the car and the miles driven, they do have a positive association. Means when you increase the age of the car, the miles driven is going to be increasing as well. Okay, look at this example, negative trend. The birth date of a country and that country literacy rates. Okay, you're gonna see all the points is going downhill. So we believe these two variables has a negative association. And that means the country with higher literacy rates tend to have a lower rate of childbirth. Okay, this example, no trend. You could see all the points are here. They didn't going uphill or downhill in here. So for this example, is age associated with the running speed in the marathon? Okay, because there's a no trend here. So we could say marathon runner speed does not seem to be related to age of the runner. Okay, that's a no association. Okay, another example. This one you could see from the first part, this is going downhill and then they're going uphill here. So they do have some kind of association, but this is not the linear association. For the chapter 4, we only focus on the linear association. Okay, it has to be the straight line, either go uphill or either go downhill. So for like this example, we could say there is no linear association. Okay, strength of an association. Scatterplots with large amount of scatter or vertical variation indicates a weak association. Scatterplot with the small amount of scatter or little vertical variation indicates a strong association. So you could look at the example like here. This one, they do have a large amount of scatter. Or you could see for the vertical variation, they do have a large amount. So this is the weak associations. Versus this one, this is with the small amount of the scatter and little vertical variation. So we believe this example will have a strong association compared with this one. Is there a stronger association between the height and the weight or between the waist size and the weight? So we're going to compare with these two. So because this is a stronger association and this is a weaker association. So we're going to say there seems to be a stronger association between the waist size and the weight because this is a less vertical variation in the graph. Okay, the shape, the linear. Scatterplots that cluster around a line model linear trends. This scatterplot shows there is a linear association between the volume of search for the word vampire and the word zombie. Okay, you could see I could draw the straight line in here and then all the points is gonna be around on this straight line. And then this is gonna be going uphill. So this is a positive association. So the shape non-linear. You could see I wouldn't be able to draw a straight line in here. Okay, we do have the chance that this is a non-linear. Means the chance that are better modeled by a curve rather than a line. And this scatterplot shows there is a non-linear trend between the temperature and pollutant ozone level. Okay, writing description of associations. When writing a description of an association between two numerical variables, always include the trend. Okay, the trend is talking about is going to be increasing or decreasing. Okay, increasing or decreasing or neither. The shape, this is talking about the linear or non-linear. Okay, if you can draw the straight line from there, all the points around the straight line, that'll be the linear. or it can be about no patterns at all. Or you could see the previous example, we do have the U shape, this is non-linear. Number 3, the string. You could talk about the strong association or the weak association. Okay? In addition, mention any observation that don't fit the general trend. So this is talking about one or more data. They are far from the majority and also it's not on the straight line. You could consider this is the outlier. Look at this example. How could you describe the association between the median age of marriage of women and the median age of the marriage for the man in the 50 states and the District of Columbia? So you could think about the writing description of association. We're gonna talk about the trend, increasing, decreasing, or neither. You could talk about the shape, is it linear or non-linear? Also, the strength, is it a strong association or weak association? So you can see first, this is a positive or negative. This is a positive, and also this is a linear. Okay, so for the number 1 and number 2, you could say this is going to be positive and linear. And then think about it, the strength. Is it the strong association or weak association? It should be strong, right? If I draw the straight line here, most of the point is going to be around the straight line. So we believe association is strong. Okay? From here, they're going to explain it. The association is strong because there is very little vertical variation in the graph. I need you guys to know how to describe the association based on the trend, the shape, and also the strength. Okay, be careful describing association. Always use a phrase like tends to when describing an association because the trend you are describing has variability. The association you are describing may not be true for all individuals. Always point out any data points that appear to be unusual or not part of the general pattern. So this is talking about the outlier. Okay, let's go back to that example and then we could talk about it. Okay, this one. So for this example, if I want you guys describing the association between this scatterplot, what are you gonna write on it? Remember, think about the trend, the shape, and also the strength. First one is positive or negative. Is it linear or non-linear? You could see they are going on like this way, right? So it should be positive and linear. And then we could draw the conclusion, say this means that the older cars tend to have greater mileage. Okay, try to use the word like tend to have a greater mileage. And then is it a strong or weak association? I would say weak in here. But or you could say the association is moderately strong and some scatter is present but not enough to hide the shape of the relationship. And talk about the outlier as well. There is one exceptional point. It's just like this one, the outlier. This car is only about 6 years old, but has been driven about 240,000 miles. Okay, that's it.